Hey everybody, it's Miss Austin. I'm going to be talking about lesson 3. Sorry, my camera closed. So lesson 3 is where you start to really put the idea of polynomials together. Lessons 1 and 2 were just some real life examples. Excuse me. And so you were supposed to use Desmos with the lesson because it was a lot of interaction looking at graphs. So I will just show real quick. Um, like if you didn't know what one of the graphs was on the card sort, you could just eventually go type it in, like if you wanted to see what does an x squared graph look like. Or when it asked you to write a second degree polynomial, degree is the highest power of the polynomial. Remember, like in our investment problem, we had a bunch, like we had, to the third plus x to the second plus x, right? But we had numbers in front of those. It doesn't matter. This would be considered a third degree polynomial because 3 is the highest. And don't forget, you can't add those together. That is not x to the 6th. You can only add variables together that are to the same power. And then there was questions in the Desmos like that said make a first degree polynomial that goes through, I'm making this up, 4. Well, a first degree would be plain old x, and then that goes through the number, like goes through the y-axis at 4. That's from Algebra 1. That's a linear equation, y equals x plus 4. Maybe it asked you, let me see, it says second degree. Well, it says a third degree whose graph crosses the horizontal more than once. So let's do a third degree. Let me get rid of this one. That crosses the x. Which one crosses the horizontal more than once? I don't know. Let me add an 8. That didn't do it. What if I add an x squared to it? That seems to be doing something. What if I put a number in front of this? Ooh, that worked. Let me put some more stuff. Plus x plus 5. Oh, that moved it up. What if I did a minus 5? So the whole activity was just to really get you to explore with ideas of polynomials and what they look like. Okay, so I'm going to kind of go over the lesson summary page real quick. It says a polynomial function of x is a function given by a sum of terms. So like that problem in lesson 2 where you were adding up all the money, all those different terms were being added up, each of which is the constant times a whole number power of x. Okay, so to me, a polynomial is like a sentence. In English, you string a bunch of words together. In math, you have terms, like you might have x, you might have 20, you might have 3x squared, you might have 6x to the 5th. If I string all those together, right, that's a polynomial. I mean, you can have a polynomial of one term. That's a polynomial all by itself, x to the 3rd, just like you can have a one-word sentence. Yes. Or even the word no. Okay, right? You can have a one-term polynomial. This would be a 1, 2, 3, 4-term polynomial. And the highest degree, or excuse me, the highest exponent is called the degree. This one, look, that's the highest power. This would be a 5th degree polynomial. Okay? So if you haven't already on that summary page, you might want to highlight that. The degree is the highest exponent in the polynomial. Okay? Way back in Algebra 1, you learned about linear, right? Because look, the highest power here, there's a 1 there. That's this graph right here. So here's just some examples. I'm going to add a bunch of notes on here, right? This is just y equals x for linear. It's called a linear function. Degree, first degree. This one is a cubic. Third degree. It's called a cubic. This one is a 6th degree. You do not have to memorize these by now, okay? And that doesn't really have a special name like these do. Some more common ones, right? Y equals x squared. That's a second degree, but it has a special name. It's called a quadratic. And let's just draw a couple sketches. Maybe you saw today or yesterday, actually, 2 days ago, right? A quadratic looks like this. It could also go upside down if you have a negative. Those are quadratics, second degree. So if you want to show yourself, this is the degree. And lesson 1 and lesson 2 were just examples of polynomials. Lesson 1 was about making this box, and we were doing volume, and we had to multiply these expressions together that created, here it is right here. And when you multiplied it out, it looked like this, right? If you did the practice problems from lesson 2, we multiplied this out. You might want to go back and watch how we got that. Look at the polynomial. This would be a third degree polynomial. Highest exponent is a 3. Okay. Another thing you're going to want to know is, sometimes graphs, they don't have a max or a min like this graph, right? This graph goes on forever and ever and ever, but it has what's called relative max and mins. Like right here, this is called a relative max because in this area, that is the maximum. That would be a relative min. So with that one, actually, you know what? Miss Austin messed up. That one is actually the absolute minimum because it doesn't go any lower. That one's a relative min. Well, we're going to call this one the absolute min. This graph, right? This one goes down here forever and ever and ever. This graph doesn't have an absolute minimum. That would be considered a relative min. And that would be considered a relative max. Okay, so the whole idea is just that you start to understand what polynomials look like. Here's a real life one that we did. The degree is the highest exponent in the string of terms. Okay, you don't add them up or anything. This one would be a third degree polynomial. If there's only one term, then whatever exponent is there, that is the degree. I hope that helped, and I'll be back to do the homework. Bye-bye.